Let's see one more concept, encoders, right? So basically decoders means if you are going to take the decoders, it is going to have n input lines and 2 power n output lines. Similarly, the encoders are like just opposite to the decoders, right? So opposite to decoders means it is going to take 2 power n lines as input and it is going to produce n lines as output, right? And it is a kind of a combination circuit, right? So if you are able to observe its representation diagram, 2 power n by n, where you are going to have 2 power n input lines and I am going to get n output lines. Okay, if you are going to substitute the value of n as 1, then you will get 2 by 1 decoder. It should be encoder. 2 by 1 encoder means it is going to have how many inputs? It is going to have 2 inputs and it is going to produce 1 output. Let me call the input as I1 and I0 and output as O. Output as O, right? So basically here if I am going to pass the value 1, meaning that here we are trying to think about always in terms of high or low, that's it, right? If I am going to pass high value, what might be the answer? High. If I am going to pass low value for 0, what might be the answer? 0. See what I am trying to convey to you now. If I am going to construct a truth table for this, I1 and I0, and you are going to get output as O, right? So now if you are going to pass I1 value as 1, I0 value as 0, what it does defines? I am going to simply activating my first input. Similarly, if I am going to say that 0 and 1, I1 is 0 and I0 is 1. I0 is 1, right? When I0 is 1, what might be happen? Right? If you are able to observe, I think you are getting question, right? If you are going to take a 1 by 2 decoder, it is going to simply produce, if I am going to give some kind of input, it is going to define its corresponding output, right? If I am going to simply say that 0, it is going to get the high output at this particular location. If I am going to get 1, it is going to produce the high output at this particular location. What about the case here? Whatever, because here we are going to have two inputs. What might be the output? Right? So observe here, you have to observe one thing. If I am saying that first input line is high, your output is going to get 0. Your output is going to get low. Whereas coming to you, if your second input is high, your output is going to be high. That's you have to understand. So if I write here, so this will be 0 and it will be 1. So what is the equation for output O? I1 bar and I0. I1 bar and I0. Right? So you have to take out the min terms and you have to solve, right? With the help of K-maps also you can get directly. Right? See, O0 you can write like this, right? This is I1 and I0. When you are going to get 1 at this particular location for 0, 0, 0, 1 and 1, 0, 1, 1. For 0, 1 only you got 1. So what is the maximum subcube possible? Only 1. So if you are going to solve it, you will get I1 bar, I0. Right? So I think you are getting confusing, right? How we are getting this one? Right? It is actually, the thing is based on high voltages. We are not thinking about in terms of various kind of inputs. Like here actually with the help of two variables we are going to get 4 possibilities. But we should not think about various kind of remaining same cases. We have to think about only when one input is high, other input is low, what might be happen at the output side. When one input is low and other input is high, what might be happen at the other side. Similarly, here also we did the same thing in 1/2 decoder. If I am asking for something you have to produce output, high output at one location. That's it. Right? So if you want clarity, so try to go with this kind of this encoder. If I take 4x2 encoder, 4-bit encoder. So here in 4x2 encoder, how many inputs are there? 4 inputs are there. So I can assume it as I3, I2, I1 and I0. Right? Outputs might be O0 and O1 and O1. Right? Now observe if I am going to give 1 at this particular line. If I am going to give 1 at this particular line, what will happen? You are going to get 0 0 as output. If I am going to give 0 1 and 0 0, what might be the output? 0 1. Right? That is the advantage. That is the meaning of encoders. Okay, fine. So instead of writing like this, I will try to represent it another way. So it is for my understandability. Like it is easy for me to explain. If I say I0, I1, I2, I3, and if I say that at I0 side, if I am having the input as 1, what is the output you are going to get? 0 0. At I1, if you are going to have one input, 0 1. At I2, if you are going to have one input, 1 0. At I3, 1. So basically with the help of 4 variables, you are going to get many cases, but you should not think. When you are going to give one input for a circuit with high input, then what might be the outputs? That's it. You have to calculate here. Right? So if I represent, this should be like I3, I2, I1, I0. Right? And your output will be O0 and O1. Right? What might be the possibilities? If I am saying that 0001, what might be the output you are going to get? 0 0. What does the meaning of this one? When I0 input is high, you are going to get the output as 0 0. Right? So if we say like this, you can go with this, right? 0 1, 0 1, 0 0, 1 1 0, 1 000, you are going to get 1 1 as output. Right? So this is the way your encoder is going to be work. Right? So can you write the expression for O0? Yes, right? How? So can you take again any kind of like K-maps? You can take the K-maps, or if you want, you can write directly. O0 value is what? I3 bar. See the minterms I have to write. I3 bar, I2, I1 bar, I0 bar, plus what about another term? I3, I2 bar, I1 bar, I0. Right? So try to solve this one. If you are going to solve, I am going to take out the common as I1 bar and I0 bar, and you may get I3 XOR with I2. I3 bar I2 plus I3 into I2 bar. So I can say it is XOR. I3 XOR X2. Similarly, try to go with O1. When we are going to get minterms, I3 bar, I2 bar, I1, I0 bar plus I3, I2 bar, I1 bar, I0 bar. So try to solve it. So you can take out the common terminals as I2 bar, I0 bar. So finally you are going to get I3, I1. Very good. So now you can able to construct a circuit for this. Right? So if I am going to have the inputs I3, I2, I1 and I0, or else let me take in the new slide. Right? So you are going to have I3, I2, I1 and I0. So what might be the equations? Can you tell? So I1 bar, so O0 is I1 bar, I0 bar, I3 XOR with I2. O1 is I2 bar, I0 bar, I3 XOR with I1. I3 XOR with I1, right? Now, can you able to construct this one? So try to do it with I3 XOR X2. I3 XOR with I2. When you are trying to do I3 XOR with I2, I3 is this one, I2, XOR operation, you will get a circuit like this. Similarly, I1 bar into I0, I1 bar, right? You are going to get AND gate, and these two has to be, you are going to get O0 as output. Similarly, for O1, you have to make sure like I3 XOR with I1, I3 XOR with I1, right? I3, and if I take this one like this, I3 XOR with I1. So here I have taken it as I0. So you can make it connect like this, right? Yes. So similarly, I2 bar into I0 bar. I2 bar is this one. You are going to get I2 bar, and I0. I0 will be, again you are going to get like this. You will get one more AND gate, and finally you are going to combine with the help of this one. So you are going to get O1, right? So this is the way your 4x2 encoder circuit will look like. 4x2 encoder, right? Guys, here if you are able to observe, can you able to simplify this expression in another form? Observe here, there is not with AND gate. What is the meaning of not with AND gate? Right? Can I write like this? Bubble up of not with AND gate. Right? Can I rewrite it as NOR gate? So in some textbooks you may observe this kind of symbols also. Right? So means if I am going to have the inputs, this is XOR for what operation? I3 is going to XOR with I2, I3 and I2. What is this one? I1 bar into I0. I1 bar into I0 means I can write like this. I1, I0, I can be written like this. Finally, you may AND operation. This is what I can call it as O0. Right? Similarly, for I3 XOR with I1, right? If I am going to take this one, I3, and if I am trying to perform XOR operation, you are going to get here I3 XOR with I1. Similarly, I2 bar multiplied with I0 bar. I2 bar multiplied with I0 bar. In place of this entire thing, I can replace it with NOR gate. This is what I am going to get as O. Right? So the reason is here, just mentioned, right? AB if I am going to give, right? A complement into B complement. You are going to get the output as A complement into B complement. So A complement into B complement is equivalent to, can write like this or not? AB, what you are going to get? A plus B whole complement. A plus B whole complement, which is equivalent to A bar dot B1. Earlier we have seen. So that's the reason I have took like this. Okay now? Fine. So instead of taking this much complexity, so what I will do, I will try to simplify it in another form. Observe the value of O0, the Boolean equation of O0 is simply I2 or I3. I2 or I3. Right? How you got? Because where you are going to get the outputs one for the cases of when I2 is 1 and all the cases are 0. R means what I have mentioned it as plus. Plus is R operator. And when you are going to get this one, when you are going to have I3 as 1. So O0 I can be expressed as I2 or I3. So this is the possible only in encoders, not in all other remaining kind of circuits. Okay, because we are not considering any other kind of inputs, we are going to consider only the 4 possibilities here. Similarly, if we take out O1, what is the expression for O1? I1 plus I3. That's it, right? So if I write here, so I can write the same this as you are going to get as. So O0 is, what is the value of O0? I2 plus I3, is it correct? O1 is I1 plus I3. Sure? Right? So try to construct the circuit diagram now. Right? If you are going to construct the circuit diagram, this is I0, I1, I2 and I3. I2 and I3 is, so assume that all the vertical lines are already constructed. I2 connected with I3 with the help of OR gate. You are going to get O0 as output. Similarly, I1 constructed with I3. You are going to get O1 as output. Right? Now try to check. So to prove that this is also equivalent to this one, so you can take out any one of the input. Right? So for example, try to take out the input as 1 0 0 0. What is the output for 1 0 0? You need to have the output as 1 1, means at O0 you need to have 1, at O1 you need to have 1 output, right? So try to take out for any cases. So here, if you pass here 1, your 1 will comes here, 1 will comes here, and for I2, here it is 0, complement is 0, complement is 0, and see, observe, here I am trying to give the inputs as 1 followed by 3 zeros, right? So if I say that output at O0 is 1, output at O1 is 1, then I can say that our circuit, drawn circuit is perfectly correct, right? So can you like debug this one? Your 1 will comes to here, okay, and I2 0, 0 complement is 1, 1 will be received here, and I0, I1 value is 0, 0 complement is 1. We are getting confused now. So here I1 is coming as usual, so I1 value is 0, I1 value is 0. So here the input is what? Complement of I1, that is 1. Here the input is complement of I0, that is 1. That is 1. Right? 1 and 1 is 1. This 0 and 0 XOR with 1. 1. What about other value of this one? I0. I0 is as usual. That is 0. That is it. When 1 and 0 is 0. 0 and 1 0. So it means that the constructed circuit is somewhere wrong. AND gate. So which AND gate? For which AND gate you are trying to say? So I2 bar, I0 bar, right? So here the connection is wrong. So it should be for I0 bar. So here the connection will be for I0 bar. Right? So now here we are going to get the value 1. Right? If you are going to get the value 1, output will be 1 as usual. 1 into 1 is, again you are going to get 1. So here it is correct. What about the case for here? I2 and I3. I2 is what? 0. I3 is 1. So 0 XOR with 1 is 1. 1 and 1 is 1. So it means that the circuit is perfectly correct, right? That is the same case is for this simple circuit. So we are going to get 1 0 0, right? 1 0 0. See, the order in which you are trying to take the number should be correct. So if I take I3 as 1. So one of the input is getting high. So I can say I will get here output as 1. Similarly for O0, one of the input is again getting high. So I can say this output is 1. So means that this circuit is equivalent to the bigger circuit. So means I can able to rewrite the same sentence in this particular also. O0 as I2 plus I3 or and O1 as I1 plus I3. Okay now. Okay. So guys, basically this is the working procedure of a 4x2 encoder. Right. Similarly, you can go with the construction of 8x3 encoder or 16x4 encoder like that. And also we can able to do like implementing a larger encoder, that is 16x4 encoder with the help of 8x3 encoders also. Similarly, we can do how many counting also. We can do all those. Okay. Fine. So if you are going to take these encoders, basically it is of two types. One is non-priority encoder. Another types are priority encoders. Right. So basically, whatever things that we discussed so far, all will becomes under non-priority encoders. So meaning that we are not going to check about its priority. Like if I am going to get the input, like assume I3, I2, I1, I0. If I am going to get 0, 1, 0, 0, the output line number 2 is going to be activated directly. Right? Meaning that you are going to get O0 as 1 and O1 as 0. O1 as 0, right? This is the way we are going to work. It will becomes under non-priority encoders. So basically these non-priority encoders are useful for to convert again like octal to binary, right? Octal to binary encoder, right? So earlier what we have seen while discussing the concepts of decoders, we have seen how to convert binary to octal decoder. So which requires 3/8 decoder, 3/8 decoder, right? Similarly, here you can able to construct octal to binary conversion encoder. Right? So what kind of encoder required here? 8/3 encoder required, right? So what might be the inputs? Y7, Y6, Y4, Y3, Y2, Y1 and Y0. These are the inputs that you need to pass. And what might be the outputs? O0, O1, O2, right? So basically if you are able to observe, any kind of circuit is going to have enabler. Is it possible or not? Yes. When enabler is there, if enabler value is 0, what about the other element values? Irrespective of all the element values. So I can pass here 0 or 1. What might be the output? Output will be always 0 because circuit is in off state. Right? Similarly, if I am going to enable the circuit by making as 1, I need to define its values. You are going to get what is the value? Again 0, 0, 0. If I am going to have enabler as 1, 4 zeros, 0, 0, 1, 0, what might be the output? 0, 0, 1. Right? Similarly, for the remaining cases, try to do 0, 1, 0, 0, you are going to get 0, 1, 0. It should be 1, 0, 0, you are going to get 0, 1, 1. Very good. And the other cases are like 0, 0, 0, 1, 4 zeros, you are going to get 1, 0, 0. Similarly, 0, 0, 1 followed by all zeros, you are going to get 1, 0, 1. Enable circuit is on, 0, 1, 0, 0, 4 zeros, you are going to get 110. Enable the circuit 100, all 4 zeros, you are going to get 4 volts. So this is way you can able to use 8x3 encoder to convert octal to binary conversion. Right? Now what you have to do? What is the equation for O naught? Next you have to make the circuit construction, you need to find out its formulas. What is the value of O naught? So for simplification I am trying to make it division number. So that you can't get confused. O naught value is what? You have to take out all the min terms. This min terms is getting because of this one. Okay, so I think it is clear now, right? O naught you are going to get because of Y4 or because of Y5 or because of Y6 or because of Y7, right? Similarly, O1 you are going to get because of Y2 or because of Y3 or because of Y6 or Y7. Similarly, what you are going to get because of Y1, Y3 na, I am not checking, just I am writing, Y5, Y7, right? So now simply you can able to construct its circuit diagram, right? So what you can do, if you take Y7, Y6, Y5, Y4, Y3, Y2, Y1 and Y0 and your outputs you are expecting are O0, O1 and O2. What is O0? O0 is Y4, Y5, Y6 and Y7 and along with some OR gate you are going to get the output as O0. Right? Similarly, O1 you are going to get because of Y2, Y3, Y3, Y6 or Y7. So you are going to get Y1 as output. Right? Similarly, to get O2, you have to have Y1 or it will be Y3 or it will be Y5 or it will be Y7. So this is the respective circuit diagram for 8x3 encoder, right? Octal to binary conversion. Similarly, what you can do now for the coming class, try to do it for decimal to BCD conversion. Decimal to BCD conversion. So what is the size of encoder required here? You required to have 16/4 encoder. 16/4 encoder. Okay.